Solve this guy by graphing. This is a system of equations, and we're going to solve it by graphing. And the way you solve a system of equations by graphing is you graph each guy and find out where they intersect. This is in the form y equals mx plus b, which means my slope for this one is negative 3 over 1, and my y-intercept is 4. So let's start at 4 like so. I don't have enough space to go up 3, left 1, but I can go down 1, 2, 3, right 1, down 1, 2, 3, right 1, and one more time I can go down 1, 2, 3, right 1. Let's take our line and connect the dots like so, and there's our first line right there. My other equation, I'm going to draw in blue. I'm going to have a slope of positive 3 over 1, y-intercept of negative 2. So put a dot at negative 2, go up 1, 2, 3, right 1, and there we can see our intersection taking place. Up 3, right 1, or I could have gone down 3, left 1, like so. Take your line, draw your line, like that, like that, like that, like that. And we have these lines intersecting at that point that I just made in purple. That point that I just made in purple is the point 1, 1, which means the solution to this system of equations is 1, 1. Solve by graphing. We have 4x plus y equals 2 and x minus y equals 3. Neither of these guys are solved for y, so let's do that first. All right, the first one is just a one-stepper. Subtract 4x from both sides. Subtract 4x from both sides. Cross u out. And you are left with y alone all by itself. Negative 4x and positive 2 don't combine. I will make that negative 4 over 1x plus 2 to make it all slope and y-intercept-y. Okay? So maybe I'll graph that now. What did I graph it in purple? So let's make it purple. My slope is the number in front of x when y is all by itself. My y-intercept is 2. So I'm going to go to 2. I'm going to go up 1, 2, 3, 4, left 1. I don't have enough space, so I'll go down 1, 2, 3, 4, right 1. And I don't have enough space to do it again. No big deal. Abracadabra. Let's draw a line the best that we can. I tried to pull it, but my pen was still up. So let's do that. Let's get rid of that. See, I did abracadabra, and I thought I looked cool, and I totally lost it. I still look cool. What am I saying? All right, so we graphed that in purple. Everybody wins. Now I have to graph that and find out where these two guys intersect. So let's write out x minus y equals 3. Let's subtract x from both sides. Drop down negative y equals negative x, positive 3. Divide everything by 1 or negative 1, or multiply everything by negative 1, or just flip the signs of everything. I'll make you 1 over 1 because of the invisible 1, and then minus 3. So my slope is 1 over 1. My y-intercept is negative 3. Start at negative 3. Up 1, right 1. There's my intersection. Up 1, right 1. 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 Down 1, left 1. Down 1, left 1. Abracadabra. Let's put our line right here and put it right here. So now we can see where those guys intersect, and they're going to intersect at that green dot or red dot, or for those of you who are colorblind, gray. And it's right 1 down 2, so my final answer is going to be 1, negative 2. Solve the system by substitution. Ugh. Probably the easiest way to do substitution is take the bottom equation and solve that guy for x. So here's the bottom equation completely written out. Let's add y to both sides. So x equals 13 plus y, and now x on the bottom is all by itself. Rewrite out the top equation, but replace that x with 13 plus y. So 4 times 13 plus y plus 2y equals 10. Let's use distributive property. 4 times 13 is going to be 52, I believe. 4 times y is 4y plus 2y equals 10. Oh, am I going to get a decimal here? No, I don't think I am. Let's combine like terms. 6y. So 52 plus 6y equals 10. No, I'm not going to get a decimal. Let's subtract 52 from both sides. Subtract 52 from both sides. 6y is going to equal negative 42. Divide by 6. Divide by 6. And y equals negative 7. Now, what I could do is, since I already said right here that x equals 13 plus y, why don't I just use that equation and plug in negative 7 for y and find out that x equals 13 plus negative 7, which means x equals 13 minus 7, which is 6. So if x is 6 and y is negative 7, then that leaves me with the point 6, negative 7. And that's how you solve a system of equations by substitution. Solve the system of equations by substitution. Well, for substitution, you really need to get one of these guys equal to a single variable. And probably the easiest thing to do is do the bottom equation and either pick x or y. So in my last video, I don't even remember what I did. So let's just pick x on the bottom. Let's solve for x on the bottom. So I'm rewriting the bottom. 6x plus 6y equals 0. In order to solve that for x, we have to subtract 6y from both sides. So 6x equals 0 minus 6y, which is negative 6y. And then if we divide everything by 6, this is nice, x equals negative y. Now we're going to take that, since that was the bottom equation, we're going to take that and plug that into the top equation. So the top equation is negative 7, and since I said x is negative y, I'm going to replace x with negative y. And then keep writing the top equation, plus 2y equals 18. Negative 7 times negative y is 7y, so 7y plus 2y is 18. 7y plus 2y is 9y. 9y equals 18. Divide everything by 9. And y is going to equal 2. Now, the nice thing about this is I already found out that x is negative y. So if x is negative y and y is 2, then x is negative 2. So x is negative 2, which means now that y is 2 and x is negative 2, that leaves me with the point negative 2, 2. And that's going to be my solution. Solve the system by elimination. Well, with elimination, what you're really trying to find is make sure everything's lined up, which it is. And second off, see if you have any variables that's the same but opposite. I don't, but if I multiply the bottom row by 6, that will get me negative 6x and positive 6x, and the x's will disappear. So let me rewrite this out, changing the bottom. The top isn't going to change. It's still the same guy that it was at the very beginning. 6 times negative x is negative 6x. 6 times negative 6y is negative 36y, and that's going to equal 6 times 4, which is 24. Add the rows. 6x plus negative 6x goes away. Negative 12y minus 6y is going to be negative 48y, and 24 and 24 is 48.
Sorry, I didn't get that. Could you restate the question?
Now, Siri, I'm good. We're going to leave it at that.
I'm not sure I understand.
Divide both sides by negative 48. She's listening. Divide both sides by negative 48, and y is going to equal negative 1. Now that I have the fact that y is negative 1, I can take any of my equations and plug negative 1 in for y to solve for x. So why don't I take the top equation, because it's less sloppy, and do 6x minus 12 times negative 1 equals 24. 6x plus 12 equals 24. Subtract 12 from both sides, and 6x is going to equal 12. Divide both sides by 6, x equals 2. And if x is 2 and y is negative 1, that leaves me with the point 2, negative 1. And that's going to be my guy. Solve the system of equations by elimination. Now, when you're dealing with elimination, what you really need are, for one, things to be lined up, and two, an opportunity to eliminate variables. Well, none of those opportunities are here. So maybe the easiest way to handle this is, since I see the bottom one is numbers, y's, and an x, maybe I take this top one up here and make that the same exact format. So let me just rewrite the top equation, just rewriting it the way it was, the way God created it. Okay? And I'm going to get the 6x over here. Once I get the 6x over here, I can flip everything around and make it look like the bottom. So let's add 6x to both sides like so. 0 and 6x makes 6x. That's going to equal negative 2y plus 10. Now, to make that lined up like that, I just do a little flipperooski where I move the 6x to the right, right? And it's the number and then the y, so 10 minus 2y. So that was the bottom equation rearranged. I'm sorry, the top equation rearranged to look like the bottom equation. So let's rewrite the bottom equation directly underneath it like so. All right. So I guess what I could do right now, and probably the easiest thing to do, is to make my numbers kind of small. I'm going to multiply the top equation by negative 3. And what that will do is that'll help me eliminate the x's. Now, a lot of people will be like, well, why can't you just multiply the top row by negative 11? Sure. Go ahead. Be my guest. I ain't stopping you. But this is what I'm going to do, and this helps me keep the numbers a little bit smaller. So that turns 10 into negative 30. That turns negative 2y into positive 6y. That turns 6x into negative 18x. The bottom equation stays exactly the same. 14 minus 22y equals 18x. When you add the two equations together, these guys eliminate. So yeah, the entire right side is 0, and so maybe the argument that I chose the wrong variable could be made, but again, it really doesn't matter. A variable eliminated, all is well. It's just now this is an extra step, so I don't know, fight me. What is this? Negative 16 minus 16y equals 0. Let's write that up here. I'm just rewriting it. Let me block that off. Negative 16 minus 16y equals 0. Let's add 16 to both sides. Negative 16y equals 16. Divide both sides by negative 16. And y will equal negative 1. All right. I have my y. You can take that y and plug it into any of the equations to solve for x. So why don't I plug it into the bottom equation because it's almost already solved for x, almost kinda. So I have 14 minus 22y, which means negative 1, equals 18x. So 14, negative 22 times negative 1 is plus 22 equals 18x. Add those guys together and you get 36 equals 18x. Divide both sides by 18, divide both sides by 18. 2 is equal to x, which means x is equal to 2. And since x is equal to 2 and y is equal to negative 1, that gives us a final answer of the point 2, negative 1, just like that. And as you can hear, for whatever reason, the iPad in my house turned on by itself. There's a ghost in my house. There's a ghost in the closet. I'm going to go turn that off. Thanks for watching. Like and subscribe. Write a system of equations with a solution to negative 6. Well, this is a point in the form xy. So just pick two random numbers. How about 3 and 4? If I do 3x plus 4y, if I were to use that as my solution, what I would do is in my head over here go, all right, well, what's 3 times 2 plus 4 times negative 6? Do a little bit of math. That would give you 6 minus 24, which is negative 18. So you would wrap up this guy by having it equal negative 18. See? And if I want to pick another equation, just pick two random numbers again. How about 1, or how about 2 and 5? So 2x plus 5y. Do the same thing over here. 2 times 2 plus 5 times negative 6 is going to be 4 minus 30. Adding those up gets you negative 26. So set that guy equal to negative 26, and you now have a system of equations where if you were to solve it, would give you the solution to negative 6. So that's us thinking outside the box. The school that Lisa goes to is selling tickets for the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. What is the price of each one of the senior citizens tickets and 1 student ticket? So let's call senior citizen tickets X and student tickets Y. Okay, so the first equation that we can write out comes from this sentence right here. 4 senior citizen tickets, so 4 X's, and plus 5 student tickets, so 5Y, is going to sell for a total of $102, like that. And then the next sentence about it being $126, when you sell 7 senior citizen tickets, so 7X, and 5 student tickets plus 5Y gives us that equation. So this is nice where they give us 5 student tickets in both scenarios. So what we can do is we can do this. We could do elimination by taking one of my equations and multiplying it by -1. So let's take the top equation because, by doing that, it kind of keeps things positive, literally. That gives us negative 4x minus 5y equals negative 102. The bottom equation is still 7x plus 5y equals 126. Now we add the two equations together. Negative 4x plus 7x is 3x. Negative 5y and 5y cancel out. And negative 102 and 126 is going to be 24. Divide both sides by 3. X equals 8. Now that we have x equals 8, we can take this information and plug into any one of these equations to find out what y is. So let's plug it into the bottom equation because it's a little bit cleaner. 7 times x is now 7 times 8 plus 5y equals 126. 7 times 8 is 56. So 56 plus 5y equals 126. Subtract 56 from both sides, so minus 56, cross you out. 5y is going to equal 70. Divide both sides by 5, and y is 14. Now, what does all this mean? This means the price of each senior citizen ticket is going to be X, so the senior citizen tickets is going to be $8, and student tickets is going to be 14, which I think is ridiculous. Why do old people have to pay less or get to pay less? That's not fair at all. Students rule, right, friends? Because you're probably a student if you're watching this video, not a senior citizen. And if you are a senior citizen watching this video, thank you so much. And if you've made it this far, which I'm surprised any of you have, thank you for watching. I love you. Let's solve this system of inequalities by graphing. Now, we have two inequalities already in y equals mx plus b form, or in our case, y is less than, y is greater than mx plus b form. Either way, slope-intercept. So let's graph this guy first. I have a slope of 4, or 4 over 1, and I have a y-intercept of -3. So let's go to -3, put a dot there, -3 on the y-axis, and go up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1. Okay? Easy peasy. Now, in order to graph this, there's two added things that we have to remember. Okay? First things first, if I were to use this line to graph it, this line isn't good enough. That's greater than, which means my line is supposed to be dashed. So let's make it dashed and then connect our dots. Now again, not good enough, because by doing this, we also notice that this is a greater than symbol, so we are to shade above the region. So let me get a nice yellow color and shade above the region, which appears to be over here. Okay, now when you have a steep line like we do, always view it as you either have a mountain, which is above the mountain, or below the mountain. And this is above the mountain when we graph it. So here is my shaded region above the mountain, where the dashed line is the mountain. Now, at this very moment, solutions to this top equation are going to live in this shaded region. But I don't care about just the one equation, I care about both. Now let's take a look at the other equation and how that affects everything that we've done. So let's graph the other equation in blue. Similar idea, we have a slope of negative 2, so negative 2 over 1. And then I have a y-intercept of 3. So we go to 3, put a dot there, and we graph negative 2 over 1, which is up 2, left 1, or down 2, right 1. Now we can see where these guys intersect, but keep going, down 2, right 1, down 2, right 1, down 2, right 1. This is a solid line because it's greater than or equal to. So this line right here is fine, just fine. So let's graph like so. Now, this is greater than or equal to, which means we need to shade above this solid line. So here we go, here we go, here we go. And although it's not perfect, what we see is the area that was untouched by the yellow is blue. But when the yellow and the blue meet, we have this green feasible region right here, which I'm going to label R. Now my solution is going to be any point that lives in that feasible region, including anything on a solid line but not on a dashed line. So the point 1, 2, for example, right there, lives in the green, which means 1, 2 satisfies both of these inequalities. Oh, that was a close one. Both of these inequalities. So that, boys and girls, is how you solve these system of inequalities by graphing. You're looking for where both shadings meet. Slim shading. So the rapper, remember him? M&M's? Thanks for watching. Solve by graphing. We have a system of inequalities, and our job is to solve it by graphing. Happy times. Neither of these are solved for y, so that's going to be the first thing that I do. So let me take u, okay, and solve that in purple. So I have 4x minus 3y is less than 9. Let's subtract 4x from both sides. Subtract 4x from both sides. Cross u out. Drop down the negative 3y is less than negative 4x plus 9. Divide everything by a negative 3. Now keep in mind, when you divide an inequality by a negative, you flip the sign. So negative 4 over negative 3 is positive 4 over positive 3. X comes along for the ride. 9 divided by negative 3 is negative 3. So now I have y is greater than 4/3 x minus 3. Let's graph that. My y-intercept is negative 3. Put a dot on negative 3 on the y-axis. My slope is 4/3, so up 1, 2, 3, 4, right 1, 2, 3. And can I do it again? Up to 1, 2, 3, 4, right 1, 2, 3. Nope. Can I go down 4, left 3? Nope. So those are my only 2 points. No big deal. I only need 2 points when I graph. Now, this is greater than, which means 2 things happen. Thing number 1 is you're not a solid line. You're a dashed line. So let's get a dashed line.
Okay.
Let's connect these dots.
First, you're not a solid line. Check it out.
Siri, you have become the bane of my existence. Oh, I triggered Siri on my watch too, or on my phone. Oh boy. All right, so anyway, y is greater than dash line. That's not all. We also have to shade a specific side. So we are going to shade above the line because this is greater than. So this is me shading above the line. If you think Siri is the bane of our existence, then why don't you leave a comment? Now would be a good time to do it as I spend half an hour shading this side. If you don't have an iPhone, what are you doing with your life? All right, so I shaded the above side. That one is good. So this purple inequality, all of these dots right here satisfy. So like 0, 0 works and negative 3, 4 work. But that doesn't matter because we care about shading two inequalities, so we have to find the other one. So let's do U in red. So I have x plus 3y is greater than 6. Same idea, subtract x, drop down 3y is greater than negative x plus 6. Divide everything by 3, everything by 3, everything by 3. No flipping of signs. So I have y is greater than negative invisible 1 over 3, x, and then 6 divided by 3 is 2. So my y-intercept is 2, put a dot there on the y-axis. My slope is negative 1 over 3, which is up 1, left 3, put a dot, up 1, left 3, can't. I can go down 1, right 3, put the same dot there, down 1, right 3, can't. Now let's do what we did with the last one. Literally exactly the same thing that we did. It's greater than, which means dashed line. All right, so let's do that. Connect these dots. Good job by me. Also, we need to shade above this dashed line because it's greater than. So if we start shading out here in the white, we see a nice blue line. But once my blue comes into contact with yellow, magic happens. Two primary colors meet and become green. Now, this green shaded region where the blue and the yellow meet is going to be my final answer. My solution to a system of inequalities is going to be where both of these shadings meet. And both of these shadings meet in this green area that I'll call R. So any point in this green area, like 2, 3, or negative 3, 5, is an answer, is a possible solution to this system of inequalities. You're not allowed to include the lines, though, because the dashed lines mean don't include the lines. But anything that is green is fair game, easy peasy. State one solution to this system. Y is less than 2x minus 1, and y is greater than or equal to 10 minus x. What I'm going to do is I didn't include a graph here on purpose because I'm not really going to be super picky about what my graph is going to look like. I just want to be accurate, that's all. So what I'm going to do is I'm going to graph both of these. I'm going to shade things, and I'm going to pick a point that I'm assuming is going to live in the area that we care about, plug it in, and make sure it works. So if I wanted to graph this top equation, it's y is less than 2x plus 1, so slope is 2 over 1, and it goes through negative 1, so basically it's going to look something like this. Okay, and we're going to shade below the region because it's less than, so let me shade it in yellow. I know that kind of looks like it goes through 0, 0. I try to make it go through negative 1. But again, we're not looking for perfection. We're looking for accuracy when we sketch this out. Okay, accuracy. Now let's graph this other one. I'm going to rewrite it as y is greater than or equal to negative x plus 10. Now it's in slope-intercept form. So you're starting like way up here. And negative x is going to be like a nice little diagonal right there. Okay, so we're going to shade, oh, actually, it's solid. Ooh, 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 ooh. Not that it's going to matter a ton, because I'm going to pick a dot that I know is going to work. So let's shade that in blue. All right, and then we have these green regions over here. Now, again, without making it a perfect graph, I really don't know any point that's going to definitely work. But I can estimate and check to see if it works. So, for example, if I were to say that you were 10 and you were negative 1, something like 10, 10 should be able to work, right? So let's choose 10, 10 and see if 10, 10 does actually work. So I'm going to choose 10, 10 and see if it works. So if I were to plug 10, 10 into that top equation, I get 10 is less than 2 times 10 minus 1. 10 is less than 20 minus 1. 10 is less than 19. Chekaruski. If I were to try U, not to be confused with Caillou, he's a little punk, I would have 10 is greater than or equal to 10 minus 10, which is saying 10 is greater than or equal to 0, which is also a true statement. So 10, 10 works. So I drew myself a very basic sketch. And by drawing myself a very basic sketch, I was able to get a general idea of where points should live. I chose 10, 10 because of the ease of the numbers, and 10, 10 worked just fine. Describe the location of each point in relation to the origin. So this is now a point in 3 dimensions. You got x, you got y, and you got z. So if I wanted to graph this using this graph right here, I'll show you how to do it, and then we're going to describe it using words like forward, backward, up, down, left, or right. Now the x-axis appears diagonal, but what's actually happening is it's coming out towards you. Depend that it's like a cube that you're looking at, and this is the cube part that's coming out towards you. So going forward, 4 has me starting out going 1, 2, 3, 4. Now moving along the y direction has me going left or right. Well, I'm not going left or right, but going up z, z is about that long, is going to have me go up 1, 2, 3. So that point is going to live somewhere around there. So the way to we would visualize that is we would view this as forward 4, don't move left or right, up 3. That's how we would graph that. Now let's do the same thing over here. Okay, we have again x, y, and z. So this would be going away from us, 1, 2. So we're going that way first, 2 units. Then we're going to go 4 in the y direction. So that's going to be like 1, 2, 3, 4. And then we're going to go up 4. So that's going to look like up 1, 2, 3, 4, and end up here. So imagine you going into, like you're going away from you 2 steps, right 4 steps, up 4 steps. So we would say, for this one, and we'll write it over here so I don't accidentally cut it off, we would say away 2, then we would say right 4, up 4. And that's how you would describe these 3D points in relation to the origin. Fun, fun. Plot the point 3, -1, -1. Well, 3, -1, -1 is in x, y, z format. So what we're going to do is we're going to look at this and notice that x is this weird diagonal looking axis. So we're going to go 3 in the positive direction, which is going to be towards you. So 1, 2, 3, that's where we are so far. Now y is -1, which means we go to the y-axis, which is left to right. Each y-axis is about that long, so we're going to go left 1, which has us landing right around there. Okay, z is also -1, which z is the up or down axis. Since z is about that much in length, going down 1 is going to be about that much, and we're going to end up here. So the way that you would describe this is you would walk towards you 3 steps, go left a step, and then go underground a step. And we end up right around there. So it's hard to visualize, it's hard to see it on a 2D surface like this, but that's how you would do it. Plot the point -1, -3, +1. Well, this is a 3-dimensional point, so let's label you x, y, z. Now the x-axis is this diagonal looking axis right here. And this is the positive axis, that's the negative axis. So you're going either towards you or away from you. So -1 in the x-axis has me moving away from me in that direction 1 step. So we're going to go back a step and land right there. Okay. Y is -3, which means we actually go left 3. So every y is about that much in length. So that's 1 step to the left, 2 steps to the left, 3 steps to the left, and for now, we land right there. Z being 1 means we actually go up 1. So we're going to end up right around here somewhere, and that's going to be our final dot. So what this looks like in the 3D world is you take a step away from you, you go 3 steps to the left, and then you hover above the ground 1 step up. So that's what it looks like. I mean, I know it doesn't look like that on a 2D surface like the screen, but that's what it's supposed to look like. I did my best. Write the coordinates of the point. All right, so basically we have this 3D point living right there. And my job is to find the coordinates of that dot. Well, we have our positive x-axis, which is over here, and our negative x-axis. We have our positive y-axis, our negative y-axis. We have our positive z-axis and our negative z-axis. Let's go in alphabetical order. Okay, it looks like that we're actually going back 2 spaces. So my x coordinate is going to be -2. It also appears that we are going left 4 spaces. So my y coordinate is going to be -4. And it appears to me that we're going up 1 unit on the z-axis, which means we're going to end up with +1. So at the end of the day, that coordinate right there is -2, -4, +1. Fun stuff. Find the intercepts for each plane. Well, when it says intercepts, you're thinking x-intercept, y-intercept, z-intercept. And if you're wondering, is this the same as the x-intercept and y-intercept that we did in Algebra 1? Yes, yes, 1,000 times yes. For example, the way you would find the x-intercept is you would replace y and z with 0 and solve for x. So you will go away, you will go away. Okay, so you cross both of those out. You get -12x equals -48. Divide by -12. Divide by -12. X is going to equal 4. So the x-intercept is going to be 4. And then you do it again. The y-intercept is going to have me writing this out and replacing x with 0 and z with 0. So -12 times 0 minus 16y minus 16 times 0 equals -48. You go away, you go away. -16y equals -48. Divide both sides by -16. Divide both sides by -16. And y is going to equal +3, which means my y-intercept is going to be +3. Then you do it again. My z-intercept, my zint, is going to have me replace x and y with 0. So -12 times 0 minus 16 times 0 minus 16z equals -48. These guys go away. -16z equals -48 is going to be the same exact thing that I did over here. So divide by -16, divide by -16. Z equals 3, which means my z-intercept is going to be 3. Look at that. Who would have thought that Algebra 2 piggybacks off of Algebra 1? Crazy. Sketch the plane -3x plus 2y minus 2z equals -6. Those 3 lines, you'll see why those are there. But right now, what I need to do is I need to find my x-intercept, my y-intercept, and my z-intercept. So to find your x-intercept, okay, that's going to be the point on the x-axis that my plane is going to go through. I find that out by replacing y and z with 0 and solving for x. So -3x plus 2 times 0 minus 2 times 0 equals -6. You go away. Divide everything by -3. And x equals 2 gives me an x-intercept of 2. So this is the positive x-axis. I'm going to put a dot right there at 2. I'm not going to use my lines yet. Don't need them. We're going to do the same thing with my y-intercept. My y-intercept is the same idea. You replace x and z with 0, so -3 times 0 plus 2y minus 2 times 0 equals -6. You go away, you go away. Divide both sides by 2, and y is going to equal -3, which means my y-intercept is going to be -3. Here's my y-axis. 1, 2, 3 to the left gives me a y-intercept at -3. Now I could draw one line if I wanted to, but let's just wait till the end. Let's just wait till the end. Let's find our zint, our z-intercept. All right, that's when you're going to replace x and y with 0. So -3 times 0 plus 2 times 0 minus 2z equals -6. Cross you out. divide both sides by negative 2, and my z-intercept is going to be positive 3. So here's positive 3 on the z-axis. All right? So I have my 3 dots. I'm going to connect the dots like so. All right, so let's do that. Let's do that. All right. Let's do that. And let's do that. All right. Let's do that. And let's do that. All right. Now, let's try to understand what this looks like. Imagine you're in like this room right here, which is a bedroom, and you're creating like this triangular shape that is a plane on the bedroom. That is what we drew. Now, this plane technically goes on forever, but by drawing this triangle, we can kind of see that this area right here represents possible points on the XYZ plane. So that's how you sketch it. Again, that triangle is infinite in its 2 dimensions, but this is the best way that I can draw it, and we can kind of have a nice little visual as to what's going on right there. Pretty fun stuff. Pretty neat stuff. Solve the system using elimination. Ooh, I love this. Love it so much. I can see by looking at this that I have a negative 5y, a negative 5y, and a positive 5y. And this is what you're going to do. I'm going to label this row A, I'm going to label you B, and I'm going to label you C. What I'm going to do is I'm going to use elimination on rows B and C. Why? Because the y's will go away. So let's do that. Let's focus on row B. Let's focus on row C and write those out. 4x minus 5y plus 4z equals 19. I've got regular x plus 5y minus z equals negative 20. Okay? Add the rows up. Add them up. You become 5x, you go away, you become plus 3z, and you become negative 1. So let's kind of write those together so it's nice and pretty. And you're looking at that and saying, buddy, math guy, we still have 2 variables there. That didn't do us a lot of good. I know, because I'm not done yet. Now that I have A, B, and C still there, and now that I was able to use this technique on B and C, why don't I use the same exact technique on A and C, and that'll allow my 5y's to cancel out again. So let's focus on A and write that out. Negative x minus 5y minus 5z equals 2. Row B, nope, I want row C. I want row C. I want row C. Ooh, I don't like how it eliminated some of that A. Row C is regular x. Oh, this is fun. Plus 5y minus z equals negative 20. Now you add those rows up. And not only do the y's cancel out, but the x's cancel out too. How nice. That leaves us with negative 6z equals negative 18. Or divide both sides by negative 6. In this case, because you can go further, and z is equal to 3. So this is happy news. We have what z is. Z is 3. Now, if we didn't get this, then we would solve this system of equations as if it was a regular 2-variable equation like you would have done in Algebra 1. But now, by doing this, and we find out that z is 3, I could take that z is 3 and plug it into here to get x. So 5x plus 3 times 3 equals negative 1. 5x plus 9 equals negative 1. Subtract 9, close you out. 5x equals negative 10. Divide by 5, x equals negative 2. Now that I know that x is negative 2 and z is 3, I can take any one of these original equations and find out why. So let's take the bottom one, because why not? X is negative 2, so x is negative 2, plus 5y minus z is 3, so minus 3 equals negative 20. Negative 2 and negative 3 on the left combine to make negative 5, so negative 5 plus 5y equals negative 20. Add 5, cross you out. 5y equals negative 15. Divide by 5, divide by 5, and y equals negative 3. So if x is negative 2, and y is negative 3, and z is positive 3, we get a solution of negative 2, negative 3, 3. And that's how you do it, baby. All right, buckle up. We've got solving systems of equations using elimination. 3 equations, 3 variables, and nothing matches up. So looking at this, we have some friendly numbers. I mean, we got regular x, and 2x. I can manage that. We've got negative 6y, y, and 2y. I can manage that. And even the z's are kind of manageable because you guys are the same but opposite. And you're 5y, z, whatever, same thing. Let's get rid of the x's. So what I'm going to do is I'm going to multiply the top equation by negative 2, and that'll compare with the positive 2x. I'm also going to multiply the middle equation by negative 2, and then negative 2x will also line up with 2x. So we rewrite the top equation. We've got negative 2x, right? Multiply that negative 2 out, so we got negative 2x plus 12y minus 8z equals 24. Then that middle row is going to become negative 2x minus 2y plus 8z. Ooh, how nice. Equals, no way, negative 24. Nice again. And the bottom row is going to be 2x plus 2y. Ooh, plus 5z. Nothing changes. That's going to equal negative 15. Let's label the top row A, the middle row B, and the bottom row C. All right, and let's just, take turns. Let's do A and C, or we'll do A and C, and then we'll do B and C. So row A, again, negative 2x plus 12y minus 8z equals 24. And then C was 2x plus 2y plus 5z equals negative 15. So again, I'm doing A and C here, and then I'll do B and C here. It really doesn't matter the order. If I add these two rows, you'll cross out. You'll become 24y. You'll become minus 3z, and you'll become 9. Okay? Manageable. Manageable. Now let's do the same thing with B and C. Okay, row B is negative 2x minus 2y plus 8z equals negative 24. Row C is going to be positive 2x, positive 2y, how nice, 5z, and negative 15. Okay, if I add these two rows, double magic happens, right? You'll cross out and you'll cross out. You'll become 13z, and you will equal negative 39. Which, if I want to kill two birds with one stone, divide by 13, z is going to equal negative 3 down there in the green. Now that gives me these two equations right here. 24y minus 3z equals 9. And then I have already z equals negative 3. So I could do the rest of this guy using substitution. I now know what z is. So if I take the fact that z equals 3 and plug that into the top equation, that gets me 24y minus 3 times negative 3 equals 9. 3 times negative 3 is 9. How convenient. Because when you subtract 9 from both sides, you get 24y equals 0. Divide both sides by 24, y equals 0. So I have z is negative 3, I have y is 0, I need x. And what I could do to make my life easy is, why don't I take one of these original equations, why don't I take the middle one and plug stuff in, and that'll help me find x pretty easily. So the middle equation was x plus y, which I now know is 0, minus 4 times negative 3, because z is now negative 3, that's going to equal 12. So x plus nothing plus 12 equals 12. Well, how convenient again, because when we subtract 12 from both sides, you both cross out and x is nothing. So if x is 0, y is 0, and z is negative 3, that is our solution. I've heard of 007, but 00 negative 3, what kind of private eye investigator, what is it, spy is that? Private eye spy. I spy. I spy with my little eye. You clicking the subscribe button. Thanks for watching. Love you. Bye. Solve the system of equations using substitution. 3 equations, 3 variables. Let's go. Let's label you A, let's label you B, let's label you C. And what I want to do is I want to take 2 of these lines and pick something that's already solved for one of the variables and just kind of plug stuff in. All right, so if I were to now, what I want to do is I want to take the fact that I already have like one of these guys solved for a variable. So why don't I pick B because it's already solved for Z and use A and B. Okay, replace the Z with whatever information I have. And then I'll do the same thing with B and C and replace the Z here with whatever information I have. And what that will do is that'll give me 2 new equations where the Z is no longer there. And I can solve that as a system of equations. So let's do A and B. Okay, here's my A. A is negative x minus y minus 3z equals negative 9. Okay. B is z equals negative 3x minus 1. So since z is already solved for, let's plug that into the A equation. So that makes the A equation negative x minus y minus 3 times z, which is now negative 3x minus 1, and then equals negative 9. Distribute that negative 3, and you have negative x minus y, positive 3x, positive 3 equals negative 9. Let's combine like terms. So that gets us 8x minus y, and if I subtract 3 from both sides, that crosses out and gets us negative 12. All right, so we did A and B. Now, using that same B, let's use B and C. So I'll see if I can squeeze that in. B, again, was z equals negative 3x minus 1. And then C is x equals 5y minus z plus 23 in Michael Jordan. All right, so x is going to equal, if z is negative 3x minus 1, x is going to equal 5y minus parentheses negative 3x minus 1 plus 23. That gets us x equals 5y, distribute the negative, 3x plus 1 plus 23. X will then equal, after combining like terms, 5y plus 3x plus 24. So I could use that equation right there and that equation right there and create, oh, I'm not even done yet. What am I thinking? If I subtract 3x from both sides, that gets me negative 2x equals 5y plus 24. Divide everything by 2. Ooh. And that gets me, divide everything by 2, divide everything by 2, divide everything by 2. That gets me x equals negative 5 over 2y minus 12. All right. Now that I know that x equals negative 5 over 2y minus 12, and I already have this equation in red, I can create this system of equations to help me solve for both x and y. Not going to be pretty, but you know, these things usually aren't. I know what x is now, so I'm going to plug that x into the bottom equation. 8 times negative 5 over 2y minus 12 minus y equals negative 12. 8 times negative 5 over 2 is going to be negative 20y. 8 times negative 12 is negative 96. Then we have minus y equals negative 12. Combine like terms. That's going to be negative 21y minus 96 equals negative 12. We can add 96. We can add 96. And that'll get us negative 21y equals, what will that get me? 84. Divide both sides by negative 21. Y is going to equal negative 4. Now that I know what y is, okay, I could take that and plug that into that top equation right there. So x equals negative 5 over 2y, which is now negative 4, minus 12. X is going to equal negative 5 over 2 times negative 4 is going to be positive 10 minus 12. X is going to equal negative 2. Now I still need to find z, which isn't bad because look at that. Z is negative 3y minus 1. So z is going to be negative 3x minus 1, sorry. So x is negative 2. Negative 3 times negative 2 minus 1 is going to be 6 minus 1, which is going to be 5. So if I have an x which is negative 2, I have a y which is negative 4, and a z which is regular 5, I got myself my solution. Not easy, but so much fun. This is a system of equations by substitution that ain't gonna be so bad. I'm gonna call you A and B and C. What I see is B is already solved for Z, so I want to take turns with A and B, and then B and C, and plug in Z for those Z's. Now here's the thing. The goal of all of this is to come up with two equations where now I only have two variables. Well, look at the top equation. That's already two variables. So I'm going to leave that as is. So I'm going to go with U. I'm going to leave it there. Now, I still have to use B and C and plug in that guy for Z down there to get me just X's and Y's. So I'm going to do that. So I'm going to set up B and C. So B is Z equals negative 3X minus 3Y plus 9. C is negative 4X plus 5Y plus Z equals 8. Okay? So if I replace the bottom equation, the z in the bottom equation with the z up here, I get negative 4x plus 5y plus z, which is negative 3x minus 3y plus 9. And then to complete c, I have equals 8. Okay, this parentheses, not useful. So negative 4x and negative 3x is negative 7x. 5y and negative 3y is 2y, and if I subtract 9 from both sides, I get equals negative 1. So I have my top equation, and I'll write that directly underneath to create a new system of equations. So I have 7x minus 3y equals negative 6. Now, going with the spirit of substitution, I'm going to use substitution to solve this system of equations. So why don't I take the top equation? Why don't I take the bottom equation and solve it for x? That might be easier. If I solve the bottom equation for x, right, let me just rewrite it out. 3x minus 3y equals negative 6. If I solve u for x, I'm going to add 3y to both sides. 3x equals 3y minus 6. Divide everything by 3. X is going to equal y minus 2. Let's take that and plug that into the top equation. That's going to get us negative 3x, which is now y minus 2. So let me replace the x with y minus 2. So negative 7 times the quantity y minus 2, close it, plus 2y equals negative 1. Distribute, negative 7y plus 14 plus 2y equals negative 1. Combine like terms, negative 5y plus 14 equals negative 1. Subtract 14, subtract 14. That gets us negative 5y equals negative 15. Divide by negative 5, divide by negative 5, y equals 3. Now, I know that x equals y minus 2. And if I just found out that y equals 3, that means x equals 3 minus 2, which last time I checked is 1. So I have my x, I have my y, I need my z, and z just so happens to be equal to negative 3 times x minus 3 times y plus 9. So z is going to equal negative 3 times x, which is 3 times 1, negative 3 times 1, minus 3 times y, which is negative 3 times 3, plus 9. So z is going to equal negative 3 minus 9 plus 9, so these guys will just cancel each other out, and z is going to equal negative 3. So putting it all together, okay, my x was 1, my y was 3, my z was negative 3, close you up, that's my guy. So solving a system by substitution, not the prettiest thing in the world, lots of work here, but boy did I have a lot of fun. Solve using Cramer's rule on a TI-84+. This is also known as reduced row echelon form. What you do is turn the coefficients of your system of equations into a matrix and let your calculator do all the work. All right, so in order for us to make this work, we have to make sure that everything is in the order where it's alphabetical equal sign number. And that's what we have here. X, Y equals number. X, Y equals number. So that's good. What we're going to do is we're going to turn the coefficients into a matrix. So we have a negative invisible 1 living here, then a 4, then a negative 2. So our first row of this matrix is negative 1, 4, negative 2. The second row is already nice, negative 2, 5, negative 4, negative 2, 5, negative 4. Now keep in mind, this column represents x values, this column represents y values, and this column represents what our numbers equal. So let's quick go to our calculator, plug this information in, and use Cramer's rule on a TI-84+. So now that we are on our TI-84+, and this probably would work for like a TI-83+ or other TI versions. I just like using a TI-84+ because that's the one that's on my computer. What we're going to do is we need to set up the matrix that you see on the right in our calculator. You do that by hitting second, this guy, and that takes you to matrix. So we need to edit our matrix. As you can see, what we have is 2 rows and 3 columns. So when we set this up, we're going to call it 2 by 3. Whenever you're dealing with the matrix, the rows come first, the columns come second. Now, as you can see, we have exactly what we need. We just need to plug our numbers in. So our numbers were negative 1, enter 4, enter negative 2. Make sure you're hitting this negative button and not the minus sign because, you know, TI is awesome when it comes to that. Not the rapper, by the way. TI means Texas Instruments. If you're old enough to know who TI the rapper is, you probably shouldn't be watching this video. You've been held back too many times. Anyway, that should do it. Okay, so our matrix is all set up. Now let's get out of here by second, mode, and going to quit. Let's go to second, x to the negative 1 to take us back to our matrix information. Now you can see that A is programmed in. Now I'm going to use Cramer's rule. You probably heard me in the previous part of this say it's also known as reduce row echelon form. So we're going to go to math and we're going to go down and choose RREF, reduce row echelon form. So we're going to hit enter on that. Now, right now, your calculator is like, all right, well, let's take the R ref of something. We still haven't said what we need to take the R ref of. So if we hit second, x to the negative 1 to take us back into our matrices section, we can choose A, which was the matrix that we edited, close the parentheses, and we're good to go. Now, what's going to pop up is a nice looking matrix with ones and zeros and numbers. There it is. Now, what we'll do is we will write down this exact matrix going back to our notes, and I'll explain what all of this means, but our calculator step is done. Now we just need to diagnose the answer. Now, after using reduced row echelon form, we ended up with this matrix here: 1, 0, 2, 0, 1, 0. Now, the long way of explaining this answer is this. And so you will see me do another one of these problems in a video after this where I'm going to have more variables and more lines. But let me use this time to explain what this means. Again, you're an X, you're a Y, you are equals, and then here's our number. What this row here means is 1x plus 0y equals 2. Now, we can clean this up. That 0y is useless. That 1 in front of the x is also useless, so x equals 2. Oh, how nice. That's half of our answer. And this row right here says 0x plus 1y equals 0. You're useless. The 1 in front of the y is useless, and you end up with y equals 0. So the long way of doing this is saying, like, this all serves a purpose. These aren't just numbers floating around. No, when you have 1001 and then the numbers over here, this tells you that x is 2 and y is 0. And though that right there is a solution to that system of equations. So if you're looking at this problem, you're saying, whoa, 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 whoa. We could have just used our calculators to solve any system of equations. Yes. Yes, you could. But, you got to learn the math because math is kind of what I do. And how am I going to make all this money off of YouTube if I don't teach you the math part first? So this is a system of equations, 2 variables, 2 equations. In the next video, it's going to be a system of 3 variables. So, stay tuned. But again, yeah, it's as simple as you writing this out as a matrix after making sure everything's in order. As long as it's 1001, your numbers represent your answer. You're done. Solve using Cramer's rule on a TI-84 Plus. If you haven't watched my previous video about Cramer's rule, go back, watch it. It'll help you understand this a little bit better because I'm going to speed through this a little bit more. Cramer's rule on a TI-84 Plus is also called reduced row echelon form. And what you do is you take your equations, make sure they're in order alphabetically, make sure they're equaling, and make sure that they have a number. What I see here is 3 equations. I have x's, y's, and z's, so I'm going to label you x, y, z. They're all equaling their number. So I'm going to label that 2. The numbers that go in this matrix are the coefficients attached to the variables. Now what we see here is you're an x, you're a y, and you're no z. So in my mind, I'm going to imagine that there is a 0z there. Okay? So when I set up this first row, it's going to be 4, 5, 0, negative 6. My x coefficient was 4. My y coefficient was 5. My invisible z was 0. And it's going to equal negative 6. If these are not in order, put them in order. Fortunately, these are. Life is good. Now your 10x, your negative 30y, your 50z, and your equal to negative 27. This last row is 4, 4, invisible 1, negative 6. So 4, 4, invisible 1, negative 6. Now is the time where we run over to our computer, or calculator rather, and do all the work that we need to do and pump out an answer. So let's go off and do that quick. Cramer's rule. So, and if you're a big fan of Seinfeld, you would agree with that. Although I never watched the show. Never got into Seinfeld. I was more of an Office kind of guy. But anyway, I digress. Cramer's rule. What we need to do is we need to take this matrix over here and plug it into here and do reduce row echelon form. So how do I make all this information into the matrix in my calculator? Hit second x to the negative 1, and that takes you to the matrix section. Now, I have to edit a matrix first. What we're looking at over here is 3 rows and 4 columns. So when we select the first one to enter, we're going to choose 3 by 4 to make it 3 rows and 4 columns. If for any reason you get it backwards, just type out the numbers you're supposed to type out and you'll be fine. Now, here we are exactly where we need to be. So this is the part where we type stuff in. So 4, enter, 5, enter, 0, enter, and make sure you use -6 and not -6 because, TI-84 pluses are the best. 10, enter, -30, enter, 50, enter, -27, enter, 4, 4, invisible 1, -6. All right, so you match up with what we have over here. Everybody's happy. Everybody wins. Let's get out of here. Second mode. Now I have to do reduced row echelon form. So what I'm going to do is I'm going to go back to my matrix category by hitting second x to the -1, and I'm going to perform a math operation on it. Now our ref is way down here at B. You got to hit down a bunch of times. Okay, so we're doing reduced row echelon form R ref, not ref, R ref. Now, right now, our calculator is just thinking, all right, well, let's take the R ref of something, but what? So let's go back to our matrix category, second x to the -1. We're going to use the fact that we edited A and plug that guy in. Close the parentheses, and you're going to get a nice little matrix where everything is exactly what it should look like. A bunch of ones and zeros, right? Binary code, and then these numbers over here. So let's write that down and explain what that means. Okay, so the matrix we ended up getting was, again, a 3 by 4 matrix with a bunch of ones and zeros, all right? We had 1, 0, 0, half, so 0.5. We had 0, 1, 0, -1.6, and we had 0, 0, 1, and then another -1.6. Now, let's remind ourselves that this column are x's, right? This column are y's, and this column are z's, and this equals something. So common sense would tell us, well, wait a minute. So 1x plus nothing equals 0.5. So x equals 0.5. We have our answer already. So x equals 0.5, which means if I have 3 variables, I'm going to have a point involving 3 variables. So 0.5, comma. No x but a y and no z equals -1.6. So you're -1.6. And no x and no y but a z equals -1.6. So as long as these guys are in the form 1, 0, 0, blah, 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 and they kind of go in that diagonal order, we have our answer already. So if you're looking at this and saying, well, wait a minute, every single one of these solving system of equations problem, we could have just thrown under our calculator and done it. Yep. You just have to make sure that everything's in order, x, y, and if necessary, z equals a number. Plug it in, get stuff out, get an answer, you're done. And that's the end of that section. This volume is finished. So, yeah. Go back, watch all of them, like everything, comment. Comment your favorite side character from a 90s sitcom. Mine's not Kramer. Mine would 1,000% be Uncle Joey. If you know who Uncle Joey is, comment what show that is. So, anyway, that's it. I'm done. Thanks for watching. Love you.